السلام عليكم ورحمة الله. هذا الفيديو هو عبارة عن نحكي عن الكيميكال رياكشن للألكوهول. حبلش بشيء اسمه المايلد اوكسيديشن. مفهوم المايلد اوكسيديشن is the reaction in which alcohol are oxidized. أنا في عندي reaction is undergo oxidation reduction reaction. الهدف من هيدي هو is the changed functional group is it changed functional group is it changed into another functional group. يعني group ال OH group of the alcohol is it changed into another functional group without it changing or breaking the carbon chain. يعني the carbon chain of the alcohol remains the same during a chemical reaction. If alcohol is or has a linear chain carbon, the product of the alcohol will has also a linear chain carbon. If the alcohol has a branched chain alcohol carbon, so the product obtained it will have a branched chain carbon. The product obtained in the mild oxidation depend on the nature of alcohol. يعني as we know the alcohol we have three types of alcohol. في عندي the primary alcohol، في عندنا secondary alcohol and tertiary alcohol. Every one of these class of alcohol when undergoes a mild oxidation it will give a different product. Primary alcohol will give a certain product, secondary will give a different product, and tertiary will doesn't make any chemical reaction, doesn't undergo a mild oxidation. The only primary and secondary will undergoes a mild oxidation. For a primary alcohol for the first type of mild oxidation is known as catalytic dehydrogenation. The first type of mild oxidation reaction, it is a catalytic dehydrogenation. We will take three types of mild reaction or mild oxidation reaction, and these three different reactions are classified as mild oxidation. The first reaction is catalytic dehydrogenation. Dehydrogenation means that we have removing of hydrogen. Dehydrogenation يعني removing of hydrogen gas. يعني alcohol molecule will lose hydrogen gas during this reaction. إذن it is the removing of hydrogen gas from alcohol. The catalyst or the condition for this reaction is an absence of air. The reaction takes place in a flask or a closed flask, absence of air, and in the presence of a catalyst اللي هو الكبر catalyst. For primary alcohol, the primary alcohol during catalytic dehydrogenation is changed into aldehyde. إذن أنا عندي alcohol primary alcohol changed into aldehyde. The general formula of aldehyde is RCOH, or can be written as aldehyde general formula R. We can write also as RCOH as following. This carbon with oxygen is carbon double bond oxygen. Isn't the functional group of alcohol, this carbon that contains the functional group of alcohol is changed into carbon with double bond oxygen and hydrogen. This is a mild oxidation, which is the changing of the alcohol compound of the functional group of alcohol into another functional group without the changing of a carbon chain. As we look in general, we have an alkali chain or a carbon chain, it remains the same. The other product of this reaction, since it is a dehydrogenation, it will produces hydrogen gas. Is a primary alcohol in the presence of copper and heat at 30 degree. The reaction of the primary alcohol changed into an aldehyde. As I said before, aldehyde is RCO or RCO, C double bond O with H. I will give some example. Okay. In this reaction, we have andyl ethanol. Ethanol with CH3CH2OH. Upon dehydrogenation, since it is a primary alcohol, it is changed. As we see, the carbon with the hydroxyl group is changed into C double bond O and H. As we see also, the R group, the carbon chain in ethanol, is CH3 remains CH3. So we change the CH2OH group into C double bond OH. The other product is hydrogen. If I want to take the other example, propanol, this carbon of the functional group or hydroxyl group is well changed into C double bond OH. And we replace the carbon of the hydroxyl group with C double bond OH in order to change into aldehyde, and the remaining part of the alcohol will remain the same. So the product obtained, if I want to write the condensed structural formula of the aldehyde produced in this reaction, is CH3 CH2, this carbon shall remain the same C, and we replaces the alcohol group with C double bond OH plus the other product is a hydrogen gas. Okay, for secondary alcohol is, as we know, secondary alcohol, the OH group or the functional group is inside the carbon chain. We have R, CH, OH. This is a secondary alcohol. When undergoes dehydrogenation reaction, it is changed into a ketone. This is the general formula. Of ketone. In the chapter of aldehyde and ketone, we will take the general formula of aldehyde ketone and how to name aldehyde and ketone. In this chapter only, we want to know how to change the functional group of alcohol into either aldehyde if it is a primary alcohol, or into ketone if it is secondary. Also ketone, we can write it as RC double bond O, RC double bond O, and the other part remains the same. We only change the carbon of the functional group. This is the mild oxidation. We're changing the carbon of the functional group into another organic compound. Also, in this example, we have the following two secondary alcohols. The first is 2-propanol. 2-propanol is an secondary alcohol. The functional group is inside the chain. As we see, the functional group or the carbon containing the hydroxyl group is changed into a carbonyl group. This is known, C double bond O is known as carbonyl group. As we see, CH is changed into OH. CH is changed in CH. OH is changed into C double bond O. The other part of the alcohol molecule remains the same. We doesn't change the position of the carbon atom. The carbon atoms remain, or remain in the same position with the same number of hydrogen. We don't change the number of hydrogen atom. Every carbon has CH3, so in the product each carbon will have CH3. We don't remove or add any or change or displace the number of hydrogen atom. The other product, since it is a dehydrogenation, the other product is hydrogen gas. If I want to apply this reaction to this secondary alcohol, only I want to replace or to change this carbon with the hydroxyl group into a carbonyl group, and the other part of carbonation will remain the same. This part I don't change anything of it, and this part I don't change anything in it. So the product will be CH3 is the first carbon atom, the methyl group CH3. I change the functional group CHOH into a carbonyl group C double bond O, and the remaining part will remain the same, CH3 and CH3. I conserve the carbon chain in the molecule the same without changing the carbon chain. This carbon chain in alcohol is a branched chain carbon. It will be a branched chain carbon with the same carbon, with the number of carbon, with the same number of hydrogen. We only change the functional group. We only change the functional group of alcohol into a carbonyl group, and this product is classified as a ketone. So secondary alcohol upon catalytic dehydrogenation will change into ketone compound in addition to hydrogen gas. This is the catalytic dehydrogenation for a primary and secondary alcohol. So primary and secondary alcohol undergoes catalytic dehydrogenation, whereas tertiary alcohol doesn't make any reaction.